it's time for us to work on implementing our transform. Okay? So we have the transform type and it allows us to group things together, but we can't actually do transformations. What are transforms? In 2D graphics, typically these transforms are what are called affine transforms, and these are things in which you can manipulate the image where lines that are originally parallel stay parallel. There are effectively 4 types of affine transforms, and you can find these for the ScalaFX scene graph in the ScalaFX scene.transform. There's a rotation, a scale, a shear, and a translate. Now, we're not drawing using the ScalaFX scene graph. We're kind of implementing our own, and we are drawing to a canvas. So if we go to the canvas type, and we scroll down a bit, we will see that there are methods for doing things like rotate, scale. The scale can be done in both an X and a Y, as well as just calling a normal method to scale things. Oh, sorry, I'm on the canvas. I actually want to be on the graphics content, because this is what we actually draw to. Okay, here we go. So we have a rotate, where we specify in degrees how much we want to rotate, a scale, specify how much in X and Y. We have a translate down here at the bottom, and there's also a general transform where we can specify some different elements. Turns out these transformations are done with matrices. One thing that you might notice here is it's missing a shear. And you can probably picture inside of your head what a translate does. It just moves it around in X and Y. Obviously lines stay parallel. Rotation, you can picture what that does. Scaling, you're making it larger or smaller. The shear, you should think of as kind of pushing stuff to the side. We'll see what this looks like on an image, but we will have to set it winds up being set by these cross terms that they go basically pushing Y into X or X into Y. So we want to implement this inside of our draw transform. Turns out all of these transforms need some values, but they don't need more than 2. Okay, so we have, actually I already have a children in here, and if we don't have a properties panel yet, let's go ahead and let's pull our prop panel over, because we are going to need that. So we have the children, we have prop panel, we're going to need to keep 3 other pieces of information. One of them is something that tells us which type of transform we're actually going to make, and we'll talk about how we're going to implement this in just a second. I also need 2 basically doubles, 2 numbers. So I'll call them value 1 and value 2. Now the meaning of these varies depending upon the transform type. So for example, if this is set to be a translate, then this would be how far we move in X, this would be how far we move in Y. If it's a rotate, we don't use the second value, and the first one is an angle in degrees. Okay, so the interpretation of these is going to be a little bit different depending upon the transform type that we have. And now we need to ask the question, well, how do we want to store this transform type? It's one of these values that has 4 possibilities: a rotation, a scale, a shear, and a translate. Well, if you remember from not that long ago in the videos, we talked about enumerations. This sounds like a perfect example for enumeration. So for the time being, I'm actually going to create a companion object here. I could see making a separate transform type, but I'm just going to keep things all in one file. I'm going to put this in a companion object, and I'm going to make this extend enumeration, and then we declare the different types of rotation or transformations we can have. So we have a rotate, we have a scale, we have a shear, and we have a translate, and each of those we set equal to value. And so we could start this off, say for example, I want this to be draw transform dot translate. So by default I'm just going to move stuff around, and I'm going to move it 0, 0, so it really doesn't do anything. Okay. So how would we make this work inside of our actual draw method? So before we go and draw all the children, we have to apply our transform. So I'm going to do this with a match statement. So based upon what the transform type is, I'm going to have a case for each of the different types of transforms. So a draw transform dot rotate, and we also have the scale, the shear, and the translate. Okay, so what happens when they say to rotate? Well, we take the graphics context and we rotate it by value 1, which will be in degrees. If they do a scale, gc dot scale by value 1, value 2. They do translate by value 1, value 2. The shear is a little bit harder because the GC does not have, there is no shear. I have to use the more general transform here, and for this I need to know a little bit about how these transformations work. Turns out the first element needs to be 1.0. The second element is going to be our value 1. The third element is our value 2. The fourth element is again 1.0. Those two elements, by the way, are doing scalings. Since I'm not trying to scale, if I could do all of these just through transform. So if I were doing this for a scale, I would set the first and the second to be value 1 and value 2. If I wanted to do a rotate, I would have some sines and cosines in here, and for translate I would set these last two. Since I don't want to translate anywhere here, I can do that. And you could combine things. Turns out that any combination of these affine transforms is another affine transform. So that would set the transformation and then draw all the children. Now, once we've drawn them all, we kind of need to undo the transformation. That can be a challenging thing to do if we try to do it manually, but it turns out that the graphics context gives us a little bit of help. There is a method in here called save that basically saves off the different settings that we're using for drawing. So then we can change those settings, and when we're done, there's a restore method which will go back and restore the value that was saved here. So this allows us to keep track of what our transformation and other settings were. Then we draw all this stuff, and then we basically come back to what we had been before. Okay, in order to make this so it takes effect in our program, we're going to have a properties panel. Now, this properties panel, for the most part, can look a lot like the ones that we've done for the text and our rectangle. Of course, there are some differences. We do need to make the V-box. We don't need a color picker on this because there is no color for our transformations. Instead, we're going to have two fields. We're going to have a field for value 1 and a field for value 2. So instead of X field and Y field, I'm going to call this V1 field, and this one will be V2 field. Okay, so that automatically changes the names on those things. I need to change the other parts. So this one, it could be modifying the x, or it could just be an angle. So I'm going to put x slash theta. And this will be value 1 to string and value 1. V2, if it's ever used, is always y. And we still haven't made it so that these can draw, or so they refresh the drawing. The other thing that we need to do, though, is we need to be able to set the type of transformation. And so for that, I'm going to use something called a combo box. So I'll call my variable combo. It's going to be a new combo box, and I want it to be each of those different draw transforms. Fortunately, one of the things that enumerations have is the ability to get values, which is technically a set of the values. The combo box needs a sequence, so we can call toSequence on that. Import our combo box. And now this can be added inside of our GUI down here. I can just say combo. And we need it so that when they select something from here, that winds up becoming the setting on our transform type. So similar to what we've done before, we can set an on action, because this is just a simple selection of something, and so it invokes the on action. Because we are doing the action event in here, I can do an import, but we'll find that we need that additional import here, ScalaFX dot includes dot underscore, so that it knows how to do a conversion from the function type to what it needs for the on action. And I want to set the transform type to be equal to what's selected in the combo. So just like with our tree, the combo box has a selection model and it has a value. So I'm going to use the parentheses here. It's called the apply method. Value and apply once again do the same thing. And then I want to get the selected item and get its value out. Okay, so this, if the type didn't match up here, we'd get a type error because I'm assigning to a var. And then let's do the thing that I can't do still, which is refresh the drawing, because we've just changed the way in which this transform is going to alter things. Okay, so this should give us the ability to set things on the transformation, which would alter how stuff was drawn. To be able to see this, we should run our program. We can add a rectangle, and then inside of the transform, I'm just going to do this once. I am going to set this to be a rotate of 45 degrees, and once again, the only way that we currently have of refreshing the drawing is to actually add something new into here. So I'll add some text, and you can see this gets rotated 45 degrees. Okay, so our transforms work. We really need to come back and make it so that the drawings update whenever we change something, so we don't have to keep adding new stuff in there. But you now have seen how transforms work, the general idea behind them, and how you can make them take effect when we are drawing to the graphics context of a canvas.